In this video, we're going to look at horizontal shifts for parabolas. Remember that we have the standard form y equal to ax squared plus bx plus c, where a, b, and c are real numbers. And we always choose a not to be 0, otherwise the first term ax squared will disappear and then we are just back with a linear equation. But we also have another standard form, and that is this one, y equal to a times x minus b squared plus q. Now I'm going to use this form to show you the horizontal shifts. So in this case, p and q is the turning point of the parabola. This is where we will find the minimum or a maximum of a parabola, and what is not shown here on the view is just a may not be 0, just as we had there before the other standard form. So we're going to consider simple parabolas in this form, but we're going to take a equal to 1, which is positive, and we're going to take q equal to 0. So we're not going to deal with vertical shifts as well. Consider three functions: f of x equal to x squared, the mother function, g of x equal to x plus 1 squared, and h of x equal to x minus 2 squared. In order to draw the graphs, we're going to compile a table, and in this table we can also see how the graphs will shift in relationship to the mother graph. We are looking at these simple parabolas. First of all, if you look at f of x, this is our mother graph, and we know the values here. We're going to compute some values for g of x and h of x. You will note that I've added more values here. You will see why I did that. Let us look at the function g. So if I put in minus 2, if I substitute it into there, I will get minus 2 plus 1 squared. That is the same as minus 1 squared, which is equal to plus 1. If I put in minus 1, I will get minus 1 plus 1 inside the bracket squared. That is 0 squared, and that is 0. If I put 0 in here, then I get 0 plus 1 squared. That is equal to 1 squared, which is equal to 1. What I want you to note here is for x equal to negative 2, I get the same value as that I had for x equal to minus 1, which is 1. So it's like that. And for x equal to minus 1, I get the same y value as I had for x equal to 1 before, and for x equal to 0, I will get the same value as I had for 1 before. So what happened is everything shifted 1 unit to the left, and we will also see it on the graph. So let us look at the second one here, x minus 2. If I plug in minus 2, I will get minus 2 minus 2 squared, which is equal to negative 4 squared, which is equal to 16. We're not interested in that value. So let us look at 1. If I put 1 in here, I get 1 minus 2 squared. I will get negative 1 squared, which is equal to plus 1. And if I put in 2 here, 2 minus 2 squared, I'll get 0 squared, which is equal to 0. And if I put in 3 there, I get 3 minus 2 squared, that's equal to 1 squared, which is equal to 1. So in this case, what happens now at 1 happened at minus 1 before. And what happens at 0 before now happens at 2. So these values here are the same, and this value and that value is the same. So we see that in this case we've moved from there to there, so that is 2 units. and in this case we've moved 1 unit to the left, and then so it's -1. So we see here, if we look at this blue-green line here, we see we've moved 2 units to the right. From 0 to get 0 again, we've moved from 0 to 2, that's 2 units, and from 1 to 3 is also 2 units. So every time we've moved 2 units from the original graph. So let us now indicate that or show that on the graph. On this graph you will see the green graph, which is our function y equal to x squared, our mother graph. And the red graph now represents y equal to x plus 1 squared. What I want you to note is that x plus 1 is the same as x minus 1 squared. And this -1 here is our p-value. P-value is equal to -1. And this is the -1 that you see here. So if we look at the shifts, you will see that point A has moved 1 unit to the left. The origin has moved 1 unit to the left. And point B has moved 1 unit to the left. So the whole mother graph, the green graph, shifted 1 unit to the left because we have this x plus 1 squared. Sometimes you think of it very complicated and you think, okay, we must remember it's different, shifting to a different side, but it's because the p is -1 that we're shifting 1 unit to the left. On this graph you will again see the mother graph y equal to x squared, and this was our y equal to x plus 1 squared. And the blue graph is y equal to x minus 2 squared. So if we look again at, we had that greenish color there to see the shift. So if I look at the origin, and then the next point I will find is at Q. So from 0 to Q we've moved 2 units. From A to our next point, which coincidentally intersects with the mother graph, there's 2 units. And if I take my point B and I move it to the next point there, that's also 2 units. In this case, my P is equal to plus 2, so we've moved 2 units to the right.